Question one today is on mixed liquor inventory. It says a treatment plant has a flow of 2.0 mgd with an influent COD of 240 mgl. If the desired FM ratio is 0.4 pounds of COD per pound of MLVSS per day, calculate the MLVSS inventory in pounds in the aeration system. So let's start this off right. Let's make that a little thicker and we're good. All right, so first let's find the amount of COD in our influent. So we have to use first the pounds formula, which is flow times concentration times 8.34, which is our constant, and that'll equal pounds of COD. So our flow is going to be 2.0 mgd, and it has to be an mgd. And then 240 mgl as our concentration. And then we do 8.34, and that's going to equal 4,000, uh, 3.2 pounds of COD. So pounds of COD. And then we're going to put that into our FM calculation, which F is the COD and M is the microorganisms or MLVSS. So 4,003.2 equals 0.4 for our FM ratio, and we do not know our MLVSS, but that'll be our, let's just say, X. So we're gonna move this on this side by dividing it. So 0.4 divided by uh 4,003.2 is going to equal a 0.00009. So we're going to get the inverse of that, but instead of having to get the inverse, we're just going to flip these numbers over because this side, once you take this out, it's just going to have that 1. So 1 divided by x equals this number right here. But if we flip this around, it'll be x divided by 1. So 4,003.2 divided by 0.4 equals 10,008 pounds of MLVSS, and that's our answer. All right, next we have a secondary clarifier, has a diameter of 100 feet and receives a flow of 4.7 million gallons per day. Determine the surface overflow rate in gallons per day divided per uh, foot squared. So we're going to convert this to GPD. So 4.7 times 1 million, because there are 1 million gallons in a million gallons. So we just convert that, and that will equal 4.7, 4,700,000 gallons per day. And then we're going to convert this using our calculation. So it'll be 0.785 times 10 feet squared. And that's going to be 78.5. So We're going to put gallons per day on top. So 4,700,000 divided by 78.5. And that equals 59,872.611 gallons per day. Sorry, gallons per day per square foot. Let's see where'd our number just go. There we go. So GPD per foot squared, because this right here is GPD and this is foot squared. All right, next. It says a circular clarifier has an effluent uh weir that is 80 feet as at a flow of 2.7 mgd. Calculate the weir overflow rate in gallons per day per foot. So we have 2.75 mgd, but we have to convert that to GPD, so we're going to multiply that times 1,000,000, 3, and that's going to be 2,750 million, and we're going to divide that by foot because we have GPD per foot, so 2,750,000 divided by 80, and that equals 34,375 gallons per day per foot. All right, next we have a plant. We have a chlorine feed rate question. So it says a plant flow is 6.4 mgd. The chlorine dosage is 4.1. Calculate the required feed rate in pounds per day. So this is easy. This is just using the pounds formula. So it's 6.14 times 4.1 times 8.34, and that's going to give you 209.951 pounds per day. Next, we have uh a digester loading question. So it says a digester receives 14,500 pounds per day of volatile solids and has a volume of 110 feet cubed. A cubic feet. Calculate the solids loading rate in pounds per day per cubic foot. So this might seem like it's like super hard, but it's actually really easy because you have pounds per day right here on the first half, and then you have cubic feet on the second half. So you know you're gonna have to divide 14,500 right here for pounds per day in the first half divided by cubic feet, which is 110,000 cubic feet. And that is going to be a volatile solids loading rate of 0.132 pounds of volatile solids per day per cubic foot. So pounds of VS per day per cubic foot.